Alright, this is 4i notes. We're going to be looking at word problems on the video today, and then the regression will be in class. Alright, so look at our first problem. If a bionic mouse has a parabolic jump, so that means when he jumps, he's going to make a parabola, okay, is looking for food and has encountered a 5-foot fence. So he's coming along, he's going to climb a 5-foot fence. Can't go around it, can't go through it, he has to go over it. Will he be able to continue in his travels if his parabolic equation for the jump is y equals negative 0.025x times the quantity x minus 30, where x is his horizontal distance in feet? Explain why or why not. So let's think about this. When is this mouse, our little bionic mouse down here, when is he going to be able to clear that fence? Hopefully you said if the max value, if his max value here, so this is going to be the vertex of our parabola, if his max value, so that was going to be the y value of the vertex, is greater than 5, he's going to be able to clear the fence. Alright, so we need to find the vertex of this parabola. Alright, what form is this? Well, I hope you said it's intercept form. So let's use our formulas for intercept form to find the vertex. Alright, so when it's intercept form, we need the zeros. So here we have x equals 0 and x minus 30 equal to 0. So our two zeros are 0 and 30. Just to find the vertex, you're going to average the zeros. So the x value is 15. To find the y value, you're going to plug the 15 into that equation. So everywhere we have an x, we're putting in a 15. Alright, so take a moment, use your calculator, and you will be able to use calculators on things like this. Okay, sure don't even need to be able to show me the work, but you can use a calculator to do that arithmetic. Alright, hopefully you got 5.625 feet. So our answer here, and explain why. Since the max is equal to 5.625 feet is greater than 5, then the mouse will clear the fence. Okay? So notes here, anytime you're looking for the max distance, you want to find the y value of the vertex. Okay, so if I write it, you should probably write it. Probably something you're going to need to know in the future. Alright, so we're just going to be going through and doing some of these application questions. Alright, let's look at the following question. Let's move this out of the way so we can see what's going on. Okay. Alright, the formula for an object launched or thrown with force is h is equal to negative 16t squared plus v sub 0 t plus h sub 0, where h is the height of the object at a certain time t in seconds. V sub 0 is the initial velocity, and h sub 0 is the initial height of the object. So a rocket is launched from 1 foot off the ground, so that's your h sub 0, that 1 foot, with initial velocity of 50 feet per second. That's your v sub 0. So the first thing you're asked to do is write an equation that gives the height of the rocket in feet as a function of time in seconds. So we're going to plug in h sub 0, 1 in for h sub 0, and 50 in for v sub 0. And that's going to be our formula, our equation. So h is equal to negative 16t squared plus 50t plus 1. So this is an equation in terms of height and time. Now we're going to use that equation to answer the following questions. What is the max height of the rocket during its flight? Alright, so max height. That means I want the y value. I need to find the vertex. And the max is going to be that y value of the vertex. Okay, so let's write down our formula again, our equation. All right, what form is this? Well, I hope you said it was in standard form. Now you have an option here. You can put it in vertex form to find the vertex, or we can use the formulas for standard form. I'm just going to use the formulas for standard form because it's going to be kind of ugly in vertex form because I got that negative 16 lead coefficient. All right, so in standard form, to find the x value of the vertex, it's the opposite of b over 2a. So that's going to give me negative 50 over negative 32, which is equal to 1.5625. And here again, you'll be able to use a calculator on this stuff. Here again, don't round this value though. Use the whole thing. This is a terminating decimal. Or you can leave it as a fraction. Okay? Alright, so now to find the y value of the vertex, we're going to take our value and plug it in. We're finding this is t. We're plugging it in for t. So negative 16, 1.5625 squared plus 50 times 1.5625 plus 1. All right, take a moment, plug that into your calculator. Don't need a graphing calculator, just any four-function calculator will work. All right, hopefully you got 40.0625, and don't forget your units. We're doing word problems, so always have your units, so that should be feet. So what's the maximum height? So a little over 40 feet is our max height. So anytime you're asked for a max or min, it's the y value of the vertex. And explain how we did the problem where there's our work. We have our math there to show our work. All right, what else they do? What do they ask us for? All right, when does the rocket hit the ground? Well, think about what's happening here, okay? This thing is starting off at 1 foot. It's going to shoot up to about 40 feet and then drop back down and hit the ground. Here's our vertex xy, not drawn to scale by any means. All right, what is this called? What vocab word is that? Well, hopefully you said it's a 0. So we want to find when the rocket hits the ground, we want to find the 0. Now remember, this is a quadratic. It has 2 zeros, but we're only interested in the positive 0 because it's starting off at 1. It's not going to have a negative 0. You can find it algebraically, but it's not in context, this problem. All right, so let's find that 0. So we've got that negative 16t squared plus 50t plus 1 equals to 0. All right, it doesn't factor. All right, so you can use completeness squared to find the 0 or the quadratic formula. Because of that negative 16, I'm going to use quadratic formulas. One of the few times I probably would use the quadratic formula because here again you do have your calculator to do the computations for you. Okay, so let's use a quadratic formula. Personally, what I'm going to do first is divide through and get rid of that negative. Okay, there's not a GCF for everybody, but I am going to divide through and get rid of that negative. Just makes it a little bit easier to work with. All right, so the opposite of 50 plus or minus the square root of b squared minus 4ac all over 2a. All right, let's start cleaning it up. So x is equal to 50 plus or minus the square root of 2500 plus 64 over 32. So x is equal to 50. All right, now remember, I only want the positive, so I'm only going to deal with the plus the square root of 2564 over 32. All right, take a moment here again, put that in your calculator, and you should be getting 3.145 seconds. So our rocket will hit the ground after 3.145 3.145 seconds. Okay? Alright, so here basically what we need on these parabolic word problems, you probably need the vertex and the zeros. That's what we're going to use each time. Alright, let's look at a different kind of problem. This has been an SOL question before. Alright, you have a city state skate park is a rectangle that is 100 feet by 50 feet. So 100 by 50. The city wants to triple the area of the state park. Okay, so the area right now is 5,000, and they want to triple it. They want to triple it by adding the same distance x to the length and to the width. So we want to add some value x to the length and to the width. Write and solve an equation to find the value of x, and then what are the new dimensions of our park. Okay, so area. So we're going to go 100 plus x times 50 plus x is equal to 15,000. We're going to have to solve for x. Now to be able to solve for x in this, we need to get this in standard form. So we're going to FOIL. So we get 5,000 plus 150x plus x squared equals to 15,000. Alright, remember we're getting this in standard form. So x squared plus 150x, subtract that 15,000, we're going to get negative 10,000 equals 0. Alright, so let's see, does this factor? It actually does factor. What multiplies to give you negative 10,000 and has a difference of 150? So it's 200 and then negative 50. And remind me in your class to show you a way to figure out, if you can't think of the factors, I'll show you a way in the calculator to find those factors. So just remind me of that when we do calculator stuff in class. Okay, so let's factor. Since my lead coefficient is 1, I can go directly to my factors. So x plus 200 and x minus 50 equal to 0. Use the zero product property. Set each factor equal to 0. So x is equal to negative 200 and x is equal to 50. Alright, well, we can't have a negative length, so we can throw away the negative 200. So that means our x is 50. Now they ask for the new dimensions. So if we add 50 to 100, we're going to get 100. And if we add 50 to 100, we're going to get 150. So our new dimensions of our park are 100 by 150. Alright, so here's some examples of word problems. We're going to finish the back of this in class, the regression, because that requires the graphing calculators. So we'll go over that in class. So if you have any questions, please write them down so you don't forget, and I'll see you in class.